Hello class, welcome to the next lesson in 8th grade Eureka Math. We're in Module 4 today, working on Lesson 9, called An Application of Linear Equations. In other words, it's how linear equations apply, how linear equations are used in the real world. So we'll need pages 81 through 92 of your workbook today. So rip those pages on out, grab some paper for your notes, and let's begin. Now, today is kind of a different kind of lesson because we finished 8 lessons in Module 4, and we have a quiz on the first 9 lessons tomorrow. So today is really, we're just going to kind of review the skills we've learned so far in this module to get ready for the Topic A quiz that we're going to take tomorrow. So we will review skills from lessons 1 through 8 of Module 4 to prepare for the Topic A quiz, and the Topic A quiz will be tomorrow. So this is all about getting ready. So getting ready for tomorrow's quiz, just getting you prepared, making sure you understand everything that we could do, while also looking at how linear equations are used in the real world. So it's a refresher of the skills we've learned and a picture, a view of how these linear equations are used in the real world. So you will today, number 1, let's get everything on there. There we go. Translate word problems into equations. First thing you're going to do is translate word problems into equations, which is what we did in a couple lessons in this module so far. Second step, you will solve the equations to see how this math works in the real world. So you're going to translate and solve. Translate and solve are the two things that we are doing today. And so because there's really nothing new, this is just kind of practice what we've already done, we're going to jump right into this. That's why there's no new vocabulary. That's why we're not really going to do any examples, because this is stuff you should be familiar with. So if you did not copy everything down, pause the video right now, copy down these notes, and then when you are ready, resume the video again, and we will get work on our exercises for today. Now, there are some things in this lesson that we are not going to talk about. Like, we are not going to talk about page 81 today. This is not something that is absolutely necessary to learn, so I'm just going to skip page 81, exercises 1 and 2. You do not have to do them today. So I just cross them out. You can cross them out on your paper, or you can just throw that paper away if you like. Instead, we are going to begin on page 82 with exercise 3. So right now, find page 82, find exercise 3, and let's read about Marvin. So what did Marvin do? Let's see. Marvin paid an entrance fee of $5 plus an additional $1.25 per game at the local arcade. Altogether, he spent $26.25. Write an equation to determine how many games Marvin played. So the games is what we're looking for. So that's going to be our variable. Games is going to be our variable. So X is going to be how many games he played. So he played an entrance fee of $5 plus an additional $1.25 per game. So $1.25 for every X. So that's $1.25X. So when he walked in the door, he paid $5 plus he had to do $1.25 for every game. So $1.25 times X for how many games he played. Entrance fee plus how much per game. And it also tells us that he spent $26.25 altogether. So that is our equation right there. 5 plus 1.25 times X equals 26.25. So that's the first step. We wrote our equation. Now we need to solve our equation. So I'm actually going to solve it over here. First thing I'm going to do is I want only the X term. So I'm going to do the subtraction property of equality and do -5 to both sides. I change both sides the same way. I do 5 minus 5, that gives me a 0. So I only have 125x, and 2625 minus 5 is 2125. Next, I only want x by itself. So let's get the x by itself. So I need to divide by $1.25, because 125 divided by 125 is just 1x. But the division property of equality tells me I do divide by 125 on both sides. Now I need to do $21.25 divided by $1.25. So I know what the answer is, but just because, well, I am pretty sure the answer is, well, what am I pretty sure the answer is? 4 makes $5. So I think he played 4 games and $5. So 17, I think the answer is, but I'm going to get my calculator out. I think the answer is 17, but I should check. $21.25 divided by $1.25 is 17. So he played 17 games. X equals 17. So Marvin played 17 games after he came in. And that's our answer right there. Marvin played 17 games. That we have 2 parts of our answer. Remember, it asks you to write the equation and solve the equation. So this is what I need to see for your work. I need to see the equation. I need to see your solution. And because this is application of linear equations, I need to see what your solution means in the context of the question. Don't just tell me 17. Tell me what 17 means in this question. So in this question, 17 means how many games he played. That's why I wrote that out. So I need to see your equation, I need to see your work, and I need to see your answer in context. So equation, work, answer in context. That's what I need. You can even write at the top of the page. I am looking. First thing I want to see is your equation. Second thing I want to see is your work. Third thing I want to see is the answer in context. Not the answer by itself, but what the answer means. Like Marvin playing 17 games is in context. Just telling me 17 is not good enough because this is application. But let's move on to number 4 and try that one. So number 4 says the sum of 4 consecutive numbers is negative 26. What are the integers? So the sum of 4 consecutive integers. Well, we're going to say x is the first integer. And we've done stuff like this before. So you should know our equation is going to be x plus 1, because plus 1 is the next integer after x, plus x plus 2, because that's the next integer, and we need 4, so we're going to do plus x plus 3. We've talked about this before. X is the first number, then we do plus 1 to get the number after it, plus 2 to get the third number, plus 3 to get the fourth number. And it says the sum of all of these is negative 26. So that's my equation. Next thing I'm going to do, I'm going to simplify my equation. I'm going to actually use the commutative property because everything is adding. I'm going to move everything around. So I'm going to get the x's, x plus x plus x plus x. And then I'm going to get the constants, 1 plus 2 plus 3 equals negative 26. Next step, I'm going to use the associative property and choose what I want to add first. The 4x's, x plus x plus x plus x gives me 4x. 1 plus 2 plus 3 gives me 6. So if you're writing your equation, because I asked you to tell me the equation and the answer in context, you can tell me this top one, that is a correct answer, or if you simplified, you can tell me this one. Either answer works. You can do either one. Those are the equations. This is just the simplified version of this one. But now that we have a simplified equation, let's solve it. Let's do -6 to both sides, the subtraction property of equality. +6 minus 6 gives me a 0. So I get 4x equals -32. It's not 20. Some people might say 20, except this is -26 with 6 more negatives. So it's -32. Then I divide by 4 to change 4x into x by itself. And division property of equality tells me I divide by 4 on both sides. So x has to be -32 divided by 4. X is -8. That is the first integer. That is the first integer. So my equation, I'm going to say, this is my equation. My answers, the first one is going to be -8. And then I do, for the next integer, -8 plus 1 is -7. -8 plus 2 is -6. And -8 plus 3 is -5. -8, -7, -6, -5 are the 4 integers. So there we go. Equation I started with and my answers. After I found the first one, I put the x up here to find the next 3 integers. Substitution. I could have done it like this, where I have x plus 1, x plus 2, x plus 3. And I could have shown the work like this. I probably should have, because I'm teaching. So if you did all that, x is -8. That's the first, second, third, fourth integers. The first is -8 because that was x. The second integer is -8 plus 1, which is -7. The third integer is -8 plus 2, which is -6. And the fourth integer is -8 plus 3, which is -5. That's where my answers came from, just in case you want me to show my work for that. But that's number 4. See how I did that? It's all about setting up the right equation, using our properties to solve it, and then figuring out what the answer means in context. Some people might just stop here and say x equals -8. Those people forgot that we needed all the integers. We don't just want x, we wanted all 4. That's why you pay attention to the context of the question. Let's do another one. Exercise 5. A book has x pages. Well, that's nice. They told us what x means already. X is the number of pages. How many pages are in the book if Maria read 45 pages of a book on Monday, half the book on Tuesday, and the remaining 72 pages on Wednesday? So she finished a book in 3 days. Good for her. She finished a book. A book has x pages. X equals Monday plus Tuesday plus Wednesday. So she finished it in 3 days. So what was Monday? Well, it says Monday she read 45 pages of a book. Well, then that means Monday is just going to be 45. Monday is just 45. Tuesday, see, 45 pages of a book on Monday. Half the book on Tuesday. Well, half the book, remember the book is x pages. So Tuesday is going to be half x pages. And then Wednesday was the last 72 pages on Wednesday. So that's just a constant. Well, there we go. Now we can use this to set up our equation. We have the book equals Monday, which was 45, plus Tuesday, which was half x, plus Wednesday, which was 72. So that's my equation. Now I need to solve it. First thing I'm going to do is I'm going to get the x's on just one side. So this 1/2 x, I'm going to move over here. So I'm going to do 1/2 x minus half x is 0. But the subtraction property of equality tells me I do minus 1/2 x on that side also. So now I get half x equals 45 plus 72. Well, now it's just adding. I'm just going to, there's the associative property. I'm going to add that first. So I get half x equals 45 plus 72 is 117. Just 117, I believe. Yes, 117. I should double, I'm pretty sure I'm right. 7, yep, 117, I'm good. Now, I don't want half x, I just want x. Well, I'm going to use the multiplication property of equality because 2 times 1/2 is just 1. 2 halves is 1. So I'm just going to multiply by 2. Some people might try to divide by 1/2. Well, dividing by 1/2 is actually the same as multiplying by 2. Just instead of dividing by 1/2, I said multiply by 2 because that's easier for my brain to figure out. So instead of dividing by 1/2, I'm going to multiply by 2. 2 times half is 1. 117 times 2 is 234. So the equation we used was x equals 45 plus 1/2 x plus 72. And that's the equation. So that's the first part of our answer. Second part is how many pages are in the book? There are 234 pages in the book. And that's the answer in context. So, equation, work, answer in context. All three things that I'm looking for. All three things that I'm looking for. Let's work on number 6. Number 6, last exercise on page 82. It says a number increased by 5 and divided by 2 is equal to 75. What is the number? Okay, so instead of a number, I'm going to say x. There we go. What is the number? What is x? So x increased by 5 and divided by 2 is equal to 75. So x increased by means plus. 5 means 5. And, now it says and, which means we have to do the beginning part first. So we want to do x increased by 5 first, and then divide by 2 is equal to 75. There we go. That is our equation. Let's just write in a different way. We have x plus 5 divided by 2 equals 75. And that's what we need to solve. That's what we need to solve. So how are we going to solve this? Well, this divide by 2 is kind of bothering me. Well, let's just use the multiplication property of equality. Kind of what we learned about in lesson 8. Multiply by 2. Because 2 divided by 2, we have a 2 in the numerator, 2 in the denominator. That cancels. But multiplication property of equality tells me to stay equal. I need to multiply by 2 on that side. So the 2 cancels on this side, and I get x plus 5. But I have to multiply by 2 on this side, so the 75 times 2 gives me 150. Then I just want x by itself. So let's make the 5 go away. Plus 5 minus 5 makes it 0. But the subtraction property of equality tells me if I do minus 5 over here, I have to do minus 5 there. 150 minus 5 is 145. There we go. That's it. I was just supposed to say what is the number, the x, the number is 45. So remember, there's my work. My equation is x plus 5 divided by 2 equals 75. And then my answer, the number is 145. That's my answer. Equation, work, answer in context. all three pieces that I'm asking for. All three pieces that I'm asking for. So those are 4 exercises. Let's go to page 83 to see what else we have that could be fun. We have exercises 7, 8, and 9 on page 83. And on page 84, we have exercises 10 and 11. So what I like to do is I like to right now give you a little bit of time to practice on your own without listening to me. I would like you to do page 83 right now, to try it right now. I want you to pause the video, try exercises 7, 8, and 9. Try page 83. And then after you get your answers for page 83, come back and check your answers with mine. So pause the video, finish page 83, and then come back and we will check your answers. But please, please do not just keep the video going. Pause it and try your best to do it yourself. And then come back and I will help you see how well you did. So I'll see you in just a minute or in a few minutes. But for me, I'm just going to keep going. So you should have paused the video. You should have worked on finish these. So let's check your work. So number 7, you read the sum of 13 and twice a number is 7 less than 6 times a number. What is the number? First thing you should have done is said, okay, so the number is going to be x. What is x? So every time we talk about the number, that's our variable. That's our x. So the sum of 13 and twice a number, twice x, is 7 less than 6 times a number, 6 times x. So now we translate the rest of the sentence. The sum means we're going to add 13 and twice means 2 times. So what are we doing with 13 and twice x, 13 and 2x? We are summing them, we are adding them. So we have 13 plus 2x. Is, that small word means a lot. It means equals. So 13 and 2x, 13 plus 2x equals 7 less than 6 times a number, 6x. So we have 6 times x, but we have 7 less than that. Now, some people might do 7 minus 6x, but that's not what it's saying. It's saying 7 less than 6 times x. So it's less than. So it's 7 smaller than 6x. So we need to start with 6x and go smaller than. You start with this and then it's smaller than what you start with. So it's actually 6x minus 7, not 7 minus 6x. English works funny that way. It's 7. Don't just translate straight across. Think about what the words mean. 7 less than means you have to start with this and then do 7 smaller than it. So think about what the words mean. Don't just translate straight across or it's going to mess you up. So translating this, let's get this into equation form without all the words. 13 plus 2x equals 6x minus 7. That is a linear equation, and we've been practicing for many lessons how to solve this. So let's solve it. First thing I'm going to do is I'm going to do minus 2x to both sides to get the x terms only on one side. That gives me 2x minus 2x is 0, so I keep the 13. 6x minus 2x is 4x, and I'm going to change the minus 7 to plus a negative 7 just to make it more clear for me. So that was the subtraction property of equality. Now I'm going to use the addition property of equality to get the x term isolated. So negative 7 plus 7 is 0. Addition property of equality tells me I have to do plus 7 on that side also. 13 plus 7 is 20, and the 4x plus 0 is just 4x. Now I isolated the x term. Now I just need to isolate my x variable. I do that by dividing 4x divided by 4, because 4x divided by 4 is 1x. But the division property of equality tells you that you should do 20 divided by 4 also. So if you did everything right, you found out that x equals 5. So hopefully you got that. If you got that, congratulations. Really well done. If you did not get that, go back and check your work next to my work and see where you might have done something different. Maybe you wrote the equation backwards. Maybe you put the 7 minus in front of the 6x. Maybe you forgot to divide. But write down whatever you did. Find your mistake. If you cannot find it, send me a message and I'll talk to you about it. We'll find it together. But our answers, remember, we have the work. I need the equation. My equation was 13 plus 2x equals 6x minus 7. And the number is 5. So I have my equation, I have my work, and I have my answer. Hopefully yours matches mine pretty much exactly. I hope yours matches mine exactly. I hope you got the right answer. Now let's check how you did on number 8. Number 8, the width of a rectangle is 7 less than twice the length. If the perimeter of the rectangle is 43.6 inches, what is the area of the rectangle? Whoa, there's a lot on this. Okay, so let's draw a rectangle. Because we are talking about a rectangle, we can draw it out. So there's a rectangle. Now, the width of the rectangle is right here. The length is right here. Okay, so there's the width, there's the length. Now, what do we know? The width of a rectangle is 7 less than twice the length. Okay, so I'm going to say the length is going to be x. I'm going to say because twice the length sounds like they want length to be the variable. So twice x is L. So I'm going to say L is x. Length is x. I labeled it right there on my diagram. Now the width is going to be 7 less than twice x. So that's minus 7. Now just like number 7, it's 7 less than twice x. So you had to start with a 2x. 2x and then 7 smaller than that. So the width is going to be 2x minus 7. Okay, so if you did this right, you found out that the length was x and the width is 2x minus 7. So length is x, width is 2x minus 7. Now what else do we know? We know the perimeter is 43.6 inches. So the perimeter is 43.6. And then what is the area of the rectangle? Well, we need to find, so we are looking for the area of the rectangle. So right here is all the information they gave us in the question. Now we need to think about how to use this. Well, they told us we know the length, we kind of know the length, we kind of know the width, and we do know the perimeter. How is the perimeter connected to the length and the width? Well, hopefully you remember that perimeter is all 4 sides. The perimeter is add all sides. We have to add all the sides. And because this is a rectangle, there's 4 sides. So for the perimeter, we need to do length plus width plus width. Because that's the perimeter. Length plus width plus width. Excuse me. So now we know the perimeter is length plus width plus width. So this can help us make an equation that we can solve and find what x is. P, the perimeter, they told us, is 43.6. Length is x. The other length is x, because L is x. The width is 2x minus 7. And the other width is 2x minus 7. There we go. We have all of that. Now let's start using our properties and solving for x. So the first thing I'm going to do is I'm going to change everything to adding. I do x plus 2x plus negative 7 plus 2x plus negative 7. Now, because everything's adding, I did plus negatives instead of subtracting. I can use the commutative property to put the x terms next to each other, x plus 2x plus 2x. And I put the constants next to each other. Now I can use the associative property and add the pieces I want together because everything is at addition. So I get 43.6 equals 1x, 1x, 2x, 2x makes 6x. Negative 7 and negative 7 make negative 14. We're getting closer. All I had to do was use the commutative property and the associative property. Now I'm going to use the addition property of equality to add 14 to both sides so that this turns into a 0. That gives me 6x equals 57.6. Next thing I need to do, I just want the x by itself, the x variable isolated. So I'm going to do divide by 6, and the division property of equality tells me I divide by 6 on both sides. So I need to do 57.6 divided by 6, and I do not feel like doing that in my head. So let's do 57.6 divided by 6. We get x is 9.6. Good. But we did not answer our question yet. Because the question is not what x is. The question is what is the area? But we can use x now to find the length and the width. So the length is just x, which means the length is 9.6. And the width is going to be 2x minus 7. So that's going to be 2 times 9.6 minus 7. 2 times 9.6 is 19.2 minus 7. 19.2 minus 7 is 12.2. So now I know the length is 9.6, the width is 12.2. How does that help me find the area? Well, you also need to remember back from other grades that area equals the length times the width for a rectangle. For a rectangle, the area equals the length times the width. And so I used the perimeter to find x. I used x to find the length. I used x to find the width. Now I can do length of 9.6 times the width of 12.2 to find the area, which is, I'm not going to do that in my head. Let's do 9.6 times 12.2. 117 and 12 hundredths. So the area is 117 and 12 hundredths. And we're talking about inches. So inches, and it's area, which means it's square inches. Wow, that was quite a few steps. I hope you were able, I don't know if you were able to figure this out on your own, but hopefully you're able to follow my my work. The area is 117 and 12 hundredths square inches. That is the solution. And we actually used a few equations for this. So, I mean, we have this equation here for the perimeter. We have this equation here for the area. So this is what your work should look like. I hope you got this answer, but I understand if you had a little bit of trouble with this one because it was multiple steps. You had to translate to find L and W to get the expressions for L and W. Then you had to remember what perimeter was to get the equation for the perimeter. Then you had to solve the equation to find X. Then you had to go back and use X to find L and W in numbers instead of an expression. Then you had to use the numbers to find the area of the rectangle. So there was like 4 or 5 steps in this question. So I understand if you might not have done this perfectly. If you did get this and you did it perfectly, very well done. Excellent work. If you did not get it, the answer I did when I did it, just so you check your work, then go back and see how I did it. Maybe you go back and re-watch this video to maybe help you understand a little bit. But yeah, that was a kind of a complicated one. Let's see how number 9 was. Number 9, we're talking about a school dance. So hopefully it might be a little bit easier than the area and the perimeter one. So we have 250 tickets for the school dance were sold. 250 tickets to the school dance were sold. On Monday, 35 tickets were sold. An equal number of tickets were sold each day for the next 5 days. How many tickets were sold on one of those days? Okay, so we have 250 tickets sold altogether. So, and it's so we have 250 equals Monday plus, and then it says for the next 5 days. So Tuesday, Wednesday, Thursday, Friday, and Saturday. So that's Monday and the next 5 days. So 250 tickets equals Monday and the next 5 days together. So Monday, it says 35 tickets. So we know Monday is going to be 35. But what about the next 5 days? Well, it says an equal number of tickets were sold each day, which means these 5 days, Tuesday, Wednesday, Thursday, Friday, and Saturday, had an equal number. So all of those, the same thing was sold. So instead, I'm just going to say, well, if they sold the same number of tickets every day, how about we just say on Tuesday they sold X tickets? And because it was the equal number for the next 5 days, that means Wednesday also sold X because it's equal to Tuesday. And Thursday sold X because that's equal to those days. And Friday plus X because it's equal to those days. And Saturday plus X. So 250 tickets means 35 on Monday and X for the next 5 days because it says it has to be equal number. So all 5 days is just going to be equal. It's all equal to X. So this is our equation. We can solve that. That's just a linear equation. Let's simplify it a little bit. Let's start with the associative property. I'm going to put all those X's together. 250 equals 35 plus 5X's, plus 5X. Now I'm going to use the subtraction property of equality because I just want the X term isolated. So I'm going to do 35 minus 35 to make 0. Property of equality tells me I'm going to do minus 35 on this side. That gives me 215 equals 5X. Now that I isolated the X term, I want to isolate the X variable. So I do 5X divided by 5 to just get 1X. I need to do 215 divided by 5, which is 43. 43. I just did that in my head, but let me check it, double check it for you because I don't want to lie to you. 215 divided by 5 is 43. So I was correct. So X equals 43, which tells me that they sold 35 tickets on Monday, 43 tickets Tuesday, 43 tickets Wednesday, 43 tickets Thursday, 43 tickets Friday, 43 tickets Saturday, because it has to be equal all those days. So my equation was, after I simplified, 250 equals 35 plus 5X. And how many tickets were sold on one of those days? 43 tickets sold on each day, Tuesday through Saturday. There's my equation, there's my work, and here is my answer in context. So that's what you should have gotten when you checked your work. If you did this on your own and you got 43 tickets, perfect, you're doing a great job. You're doing excellent work. Awesome. If you did not get that, go back and check mine to see where the difference might be. Where is the difference? But there are still more exercises to work on. So let's look at page 84 because I think we have 2 exercises left. Exercise 10 and exercise 11. So again, what I'd like you to do right now, pause the video, maybe take a stretching break because we've been doing this for a little while now. Pause the video, take a little stretching break, and then try number 10 and 11 without me. Keep the video paused, try number 10, try number 11, see what answers you get, and then after you get answers to 10 and 11, come back and check your work with mine. because I will show you how to do this. So pause the video right now, take a quick break, stretch, come back and do number 10 and 11. And when you're ready, resume the video to check your answers. But now I'm going to check the answers. So hopefully you pause the video, you did your work, and you're ready to check yours. So let's look at number 10 together and see how you did. Shauna skateboarded for some number of minutes on Monday. I'm going to say some number of minutes. Does not tell us how many, so I'm going to say the some number of minutes. I'm going to say that's my variable. On Tuesday, she skateboarded for twice as many minutes as she did on Monday. So that's 2 times Monday. 2 times Monday. And on Wednesday, she skateboarded for half the sum from Monday and Tuesday. So Wednesday was half of Monday and Tuesday. Okay, altogether, she skateboarded for a total of 3 hours. How many minutes did she skateboard each day? Okay, so Monday, some number of minutes we said was X. Tuesday, it was twice as many as Monday. So if Monday is X, twice as many is going to be 2X. On Wednesday, she skateboarded for half the sum, half the adding from Monday and Tuesday. So we have to add Monday and Tuesday and take half of it. So on Wednesday, it's half of Monday plus Tuesday. So Wednesday is half of Monday and Tuesday. So Monday was X, Tuesday was 2X. So Wednesday is add those together, then do half of that. All together, so Monday plus Tuesday plus Wednesday equals 3 hours. How many minutes did she skateboard each day? Now, already I see a mistake somebody might have made when they're doing this. Because if you are looking, they're talking about minutes, and then at the end she said skateboard 3 hours. So we cannot leave this because it's asking how many minutes. Our answer needs to be minutes. So we cannot keep hours. If we keep 3, if we say this is 3, it's going to mess up our answer because this is hours and we need to talk minutes. So instead of 3 hours, I'm going to put 180 minutes because it's the same thing. But now everything is minutes. X is the number of minutes. Tuesday is the number of minutes. Wednesday is the number of minutes. Our answer is minutes. So hours needs to go away. We cannot talk in hours. We have to keep all of our units consistent. Our units have to be consistent. But if our unit, so we change 3 hours to 180 minutes. Now we're ready to put our equation together because I know Monday plus Tuesday plus Wednesday equals 180 minutes. So I'm going to say Monday plus Tuesday plus Wednesday equals 180. Monday was X, Tuesday was 2X, Wednesday was plus 1/2 of X plus 2X equals 180. Now I'm ready to use my properties and solve. The first thing I'm going to use is actually just to use the associative property, add the numbers in the parentheses. X plus 2X. So I get X plus 2X plus 1/2 times X plus 2X is 3X equals 180. So this is the part I do first. Now I'm going to multiply that together. So I get X plus 2X plus 1/2 times 3 is 3 over 2X equals 180. Now I'm going to pick what I want to add. I'm going to add these first. X plus 2X. I get 3X plus 1.5X or 3/2 X equals 180. Now I need to add these X terms together, but I can't because the denominators don't match. So to make the denominators match, I'm going to say 3 is the same as 6 over 2. 6 divided by 2 makes 3. But the reason I use 6 over 2 is because then the denominators match. 2 and 2, the denominators match. 2, so now I can add them together. So it's not 3x, it's 6 over 2x. 6 over 2 plus 3 over 2 is 9 over 2x equals 180. 9 over 2x equals 180. Well, now I need to figure out what x is isolated. What is x all by itself? To do that, I use the multiplication property of equality. 9 over 2, I just multiply by 2 over 9. Because if I multiply by 2 over 9, the 2's cancel, the 9's cancel, I just get 1x. See, that's called the reciprocal. When you flip the fraction, when you invert the fraction, it's called the reciprocal. And a number times the reciprocal equals 1. So that's how we make 1x. We multiply by the reciprocal. Instead of 9 over 2, we multiply by 2 over 9. And that makes a 1, because that's what a reciprocal does. But the multiplication property of equality tells me if I multiply by 2 over 9 on this side, I have to multiply by 2 over 9 on that side. Which gets a little bit more complicated because now it's multiplying fractions. But you can split this up. So for example, I know that 180, well, I know 9 times 2 makes 18. So I think 9 times 20 makes 180. 9 times 2 makes 18. I add an extra 0, so 9 times 2, 0 makes 180. That's how I did it in my head. 18 is 9 times 2, so 18, 0 is 9 times 2, 0. But this lets me simplify because the 9's can simplify. 9 divided by 9 is 1. So all that's left over is 20 times 2 divided by 1, which is just means x equals 40. X equals 40. That's what it was. So x is 40. Now, so I know x is 40, but how does that help me answer the question? Because the question is saying, how many minutes did she skateboard each day? So let's talk about Monday. Monday was x. So on Monday, she skateboarded 40 minutes. Tuesday was, remember, 2x, which is 2 times 40, because x is 40, which means on Tuesday, she skateboarded for 18 minutes. Wednesday was half of Monday plus Tuesday. So that is, I can just do 1/2 of Monday plus Tuesday. Well, 1/2, Monday was 40, Tuesday was 80. 40 plus 80 is 120, and half of 120 is 60. So Monday, she skateboarded for 40 minutes. Tuesday, she skateboarded for 80 minutes. And Wednesday, she skateboarded for 60 minutes. That's how finding x helped me. So we made our equation over here. We did this work, and we found our answers right there in context. Not just 40, but it's 40 minutes. Not just 80, it's 80 minutes. Not just 60, it's 60 minutes. Because we're talking about skateboarding time. That's a lot of skateboarding in 3 days. Hopefully you got those right answers. If you got them, excellent. You're doing this perfectly. If you did not get them, go back and watch how I did it. But let's look at number 11 now, because you should have done number 11 also. Let's check it and see how well you did. In the diagram below, triangle ABC is similar to triangle A prime, B prime, C prime. And then I need the length of AC and BC. So this sounds like I'm going to use a proportion, because I know that AB is this triangle is similar to this triangle. So let's take the pieces of let's do triangle ABC and see how it is proportional to triangle A prime, B prime, C prime. So let's take the ABC pieces and let's see, we need AC and BC. So let's do AC and BC, and let's compare it with AC prime and BC prime. So AC is 10.3 minus x. BC is 5x minus 0.3. A prime C prime is 18. B prime C prime is 38. So that's how we set up our proportion. Now we need to solve this proportion. So this is actually the proportion. That's the first part of our answer because that's what we have to solve. Now let's solve it. 10.3 minus x over 5x minus 0.3 equals 18 over 38. Now you should remember from the lesson not too long ago that to solve this proportion, we're using the multiplication property of equality, and we're going to multiply the denominators by both sides. So we're going to do times 38 times 5x minus 0.3. 38 times 5x minus 0.3 right there. Now, because we do this, the 5x minus 0.3 cancels on this side, and the 38 cancels on that side. So this simplifies the proportion to make it look like something is easier to do. On the left side, we keep 38, and we keep 10.3 plus negative x. On the right side, we keep 18 times 5x plus negative 0.3. That's what we keep. Next thing we need to do is use the distributive property. Just like that. So I'm going to actually use my calculator for the distributive property because I don't feel like doing that in my head. We do 38 times the 10.3. Oh, I should clear everything. 38 times the 10.3. We get 391.4. So we get 391.4 plus negative 38x, because 38 times negative x. 18 times 5x, well, 18 times 5, I can do that in my head. That's 90, so we get 90x. Probably want to do that on my calculator. 18 times negative 0.3 equals negative 5.4. So plus negative 5.4. We're moving on. We're moving ahead. Looks simpler now. We start with a proportion. Multiplication property of equality gave us two distributive properties. We do the distributive properties. Now we're ready to work. So let's get this negative 38x out of the way because I always start with the smaller x term. Plus 38x. Negative 38 plus 38 is 0. So I do plus 38x on that side. So I get 391.4 equals 128x plus negative 5.4. Well, I'm going to add 5.4 to make that a 0. And the addition property of equality tells me I need to add 5.4 on this side also. So I get 396.8 equals 128x. I don't want 128x's. I just want to isolate the x variable. So I need to divide by 128. 128 divided by 128 is 1, so that gives me 1x. Division property of equality tells me I need to divide by 128 on both sides. So let's do 396.8 divided by 128. X is going to be 3.1. Do you see that with the glare? X is 3.1. Okay, that's a lot of work to find x. Am I done? No, I'm not done because it's not asking what x is. The question was saying, what is AC and what is BC? So let's solve those. AC, remember, is 10.3 minus x, which is 10.3 minus our x, which was 3.1. And 10.3 minus 3.1 is 7.2. So AC is 7.2 millimeters because I need it in context, remember. BC was 5x minus 0.3. Well, remember x was 3.1, so that's 5 times 3.1 minus 0.3. 5 times 3.1 is 15.5 minus 0.3, which 15.5 minus 0.3 is 15.2 millimeters. And that is, and now we are done. Now we are done. We had our equation, which was a proportion. Then we used our skills from other lessons to change the proportion using the multiplication property of equality into what looks like a linear equation. Distribute, addition property, division property, find x, and then we use x to find the missing pieces of the triangle. That might have been tricky, but I have confidence that if you've been paying attention in all of Module 4, you've been doing your work, and you've been asking questions when you should, this was probably challenging, but doable for you. So hopefully you did it. Hopefully you got the right answer, and you feel comfortable translating real-world problems into math equations and solving those equations. Let's look at the work you're going to do on your own, independently. This is the exit ticket on page 85. You can see we're going to skip number 1, but I'll talk about that in a minute. The homework helper is on page 87, but the homework helper was about the question we skipped. So page 87, you can skip page 87, and you can skip the top part of page 88. But number 2 on page 88 will help you. It is another translate and solve question. So look at number 2 to help you. Also, there's examples on page 89 homework helper. There's the homework helper number 3 on page 89, and then there's the homework helper number 4 on page 89 that will also give you more advice on how to solve these kind of problems. Then we come to page 91, which is your problem set for today's lesson. Page 91 has 7 questions on it, but you can cross off number 1. We will not be doing number 1. So for the problem set, you just need to do 2, 3, 4, 5, 6, and 7. They are real-world application problems of linear equations. So you're going to have to translate these words into equations. And then you have to solve the equation. But you can do this. Obviously, they didn't give you enough room on this page. So you're going to probably need to get some scratch paper and do your work on a separate piece of paper. Try your best on these. Have fun with these. Do your best. But remember, the problem set, my answers are on the Google Classroom. So you can check your answers with my answers. No problem. Just check your answers with mine. And when you feel comfortable, then you can get started working on the exit ticket. Oh, there's a couple more problem set questions. I forgot to tell you. There's an 8 and number 9 where you do some problem set questions with triangles. So you actually have 8 problem set questions, 2 through 9. But my answers for 8 and 9 also will be on the Google Classroom. So my answers to everything on the problem set are on the Google Classroom. Do your best. Check your answers. Ask me questions if you get stuck. And then when you feel comfortable, start the exit ticket. The exit ticket was on page 85. And because we crossed out number 1, there's only 1 question on the exit ticket. Just 1 question on the exit ticket. Just do number 2 on the exit ticket. Do your best. Take a picture of this page 85. Turn it in, and to show that you did the work for today. Thank you for paying attention. Thank you for listening. Thank you for working so hard on this. I appreciate it. Have fun. Try your best. Remember to reach out to me for questions. And I'll see you for the next lesson.